sports,
FIFA
World
Seinfeld.
Cup. Are we ready? Did we stop being stupid?
Yeah.
Okay. Hi everybody, I'm Yuval from AI21 and you're listening to YAAP podcast. Today we're talking with Niv about why RAG evaluation is broken right now and how can we fix it in certain situations. So we've seen a lot of benchmarks, right? There's a lot of saturation. Every week there's a new model that is state-of-the-art in RAG, in question answering, in grounding, another system. Now we're talking about agentic RAG. Is RAG a solved problem?
Not at all. Not as I see it.
Can you maybe give us 1-2 sentences on what's the biggest problem in RAG right now?
Most of the people are just optimizing for benchmarks that don't really represent the issues in RAG.
Which are?
The issues are usually the way that people are doing RAG by chunking or splitting a document or a set of documents into small segments and trying to search by these small segments. But these segments don't usually capture the essence of the document. They don't really adapt to any kind of questions that arrives. So, yeah.
Essentially, we're solving a local problem, right? We assume that there is an answer somewhere in a local place, somewhere in our documents, but you're saying that's not necessarily the case.
Yeah, exactly. I think that we are indexing usually in a specific way that assumes some prior knowledge about the problem. It's like going to a library without knowing the name of the author, the genre, the name of the book, or anything else. You're just assuming that you know what everyone was going to ask, but that's not the case.
Okay, and just so nobody can say that I'm a hater and just saying that everything is wrong, you did do some sort of work to find a solution, right?
Yeah, we did do some work to find a solution, and it is important to say these methods do represent a major part of the problems in the real world. When you ask questions, they are oftentimes located in localized places within document or within a single document. This is the way that people write. We write in documents and we write things in specific places. So it does make sense. But also people have a diverse set of questions that they would like to ask about documents that needs to see the documents from different perspectives and not just by chunking it into a small segment.
Okay, so there is no, it's not necessarily the case. It does represent some use cases, but it's not a one solution fit all, essentially.
Exactly.
Okay, great. So once we settle that, let's maybe dive in a little deeper. Maybe can you give me a few sentences about yourself? How come you know everything about RAG?
I don't think I know everything about RAG. I've been here in AI21 for 4 years, even before the Gen AI revolution. Worked on Gen AI, and for the past 2.5 years, we've been working on agents from different perspectives. And some of this time, I have been working on RAG. For the past year or so, I've been the head of the tools group that is mainly in charge of RAG and web search for the agent that the AI21 develops.
So just like quick tangent, maybe 4 years ago, you started work here. You called me and said, there's an open position. You have to apply. And several years later, you're here with me in a studio doing a podcast. Mm-hmm. Did you imagine that this will happen?
No, not at all.
I actually kind of did.
Okay, so that's good.
It's good. So you've handled with a lot of external tools, specifically web search and RAG. And RAG really is something that was the hype, the word, I think 1.5 years ago, right? Mm-hmm. Until agents came in and replaced it. And it's still something that we need to talk about. So let's maybe dive in more to the benchmarking problem, right? We know that benchmarks are not necessarily that represent the real world, right? MMLU and multi-question answering. Do you think, for instance, that MMLU is an actual indicator of how good a language model is?
No, I think that it has been proven and shown in many works that LLMs tend to be contaminated with information about MMLU. It represents a part of a problem. It represents some of the knowledge that the LLM acquired during pre-training, but it doesn't show the full scope. That's why usually companies that train LLMs have an evaluation suite which is much, much bigger than that.
And this is just for the LLM, right?
Yeah.
Which is something complicated by itself. But when we are introducing RAG, which is an AI system, everything gets much more complicated.
Yeah, but for some reason, I guess that the RAG benchmarking is less mature compared with the LLM benchmarking landscape.
Why do you think that is?
Maybe for two reasons. First, it has developed together with the solution. So many of the benchmarks like MTEB or BEAR are assuming a parsed document which is already chunked to small segments and questions that you can match directly to a single segment. And the question is, can I match this segment to this query? So this is the question that these benchmarks examine. On the other hand, you have generation benchmarks, the G in RAG, that already assume that the retrieval and the parsing and the chunking happened, and you get a document and you need to answer the question. But what you don't have is usually a pipeline that a benchmark that is actually benchmarking the pipeline in an end-to-end fashion, that is looking on everything. You get a raw document. It might be a PDF. It might be a docx or a PPT, and you want to parse it and to split it in an intelligent way, and you want to index it such that you can query it efficiently, and then you want to query it efficiently and correctly, and then you want to insert it to an LLM and to get the final answer. And this is the full pipeline, which is cognitively kind of impossible to do, because when you're thinking about it, the middle part, which I said quite quickly, just efficiently and correctly retrieve it from a large corpus of documents. To build such a benchmark is cognitively, I think, impossible for humans usually.
Why? You can do it efficiently and correctly, no?
Yeah, you can do it efficiently and correctly. No, you imagine that your corpus is like tens of thousands of documents, which is the case for many enterprise use cases. Then you are looking at this enormous set of documents, and what people usually do is just looking at a single document and say, okay, let's ask a question about this document, and then let's assume that we have a RAG pipeline that we can find this document or this segment by the question. But it's possible that there are 20 other documents that talk about the same thing from different perspectives, that give different answers, and you find yourself, why am I failing in this use case? But you're not really failing. You just don't know that you're not really failing.
So you're talking even about the fact that in the case that there is a local solution, there is actually a single paragraph somewhere in my thousands or tens of thousands of documents that mentions specifically the answer to the question that I have. Even then, if I will not check that this question does not appear in anywhere else, I'm in a problem.
Yeah, you need to know in advance what differentiates this specific segment from the entire corpus, which might be millions or tens of millions of segments. It's just impossible for human annotators to do this job. So most of the benchmarks, you take Finance Bench or other document question answering benchmarks, people usually look at a single document. The sophisticated benchmarks look at 2 or 3 documents when they ask a question.
Oh, I love those type of benchmarks, right? The question is always, I really love the way you say it. Can you please describe a question from there?
Yeah, if you take frames, for example, which is a great benchmark, it examines the agentic ability of agentic RAG systems and the ability to decompose a query. But to do that, because it's humanly not plausible to do that, you just compose a question synthetically in a way that's like, if my wife's name is my wife's first name is that of the 15th president mother, and her last name is like the owner of a cigarette company founded in 2015. So what's my wife's name? So it's not an actual representation of the issue, and even then, you find that there are problems with this benchmark.
Because of the same things that happened before?
Yeah, because of the same things, because it is based on Wikipedia, and information appears in multiple Wikipedia pages and not a specific page that you thought it will be. And there is information contamination with the model itself. It knows many answers to the questions. And most of the issue is just decomposing or reasoning over the question and not the retrieval part.
So you essentially do you even know where is the problem? Do you even know? It seems that it's something pretty hard if you're trying to test the system end to end. Did it fail in the generation part? Did it fail in the retrieval part? Or maybe, it failed on every level except from the fact that the language model already knew that. Mm-hmm. So you had that contamination. You get a good answer. You're really happy about that, but your system failed on almost everything that's important.
Yeah, you have a proxy for that. I can give an example. We've used OpenAI responses over the frames dataset, and you can see that in like 60% of the cases or something like that, they don't get the documents. They don't get chunks from the documents that are marked as the golden documents, the documents that you must have in order to answer the question. But they answer correctly on 70% of the data set. So something does not compile here.
I'm guessing this is...
This is the internal knowledge of the model.
Yeah, that's like a clear indication that you get for the fact that essentially these benchmarks are inherently flawed.
Yeah, exactly. They're inherently flawed.
And this is the case where the generation part is like such and such, or essentially compensating on issues with the retrieval or with the chunking itself. But I know
with
that
the decomposition of the agent.
The decomposition of the query,
yeah.
You mean?
Mm-hmm.
Yeah. But so we talked about this is what for end-to-end benchmarks, mm-hmm. right? I'm guessing that when you develop a RAG pipeline, you also... I'm actually not sure anymore. I've built the basic RAG pipelines mm-hmm. myself, but I know that every time you take it up a notch, when you have to scale it up, you have to test everything. How do you balance the trade-off between test every component or the entire system? What do you do? What can you do?
I can say what we did. We started with the naive approach, I'll call it, or we just followed the herd. We just took existing benchmarks. We tried to find the local segment that fits every question. We meticulously annotated data. And then we tried to see where we fail and how do we improve the embedding model to do these kind of tasks better. And we found ourselves optimizing around some local minima. And this is where we found out or had the understanding that many things fail outside of this small scope that we were dealing with. And once we started to look at So we were still focused on retrieval only. So that's your question. We were focused on retrieval only, but this time we tried to focus ourselves on corpus question answering data sets rather than concatenated document question answering data sets.
So you said corpus question answering only data sets?
Yeah, I mean that we wanted to simulate a use case where there is a corpus of many documents, and the question targets the corpus rather than a single document.
Give me an example.
I'll give you an example for the second one, and then we'll go back to the first one.
Okay.
Targeting a single document, Finance Bench, for example, you'll find questions like, what's the revenue? But the corpus...
Of what?
Yeah. The corpus is like 200 or 300 files of SEC filings. And the question is, what's the revenue? Because the annotator set across a single SEC filing, and he asked himself, oh, that's an interesting question. What's the revenue? But when you're coming to do it again for a corpus, you're saying the corpus of which company?
Wait, I'm sorry. I think I only right now understand. The question is, what's the revenue?
Yeah.
Question mark?
Yeah, exactly. If you take narrative QA, for example, it's a data set of short stories and questions about the short stories that is compiled as a RAG or retrieval plus generation benchmark. And then in this benchmark, you can see a question like, why was John leaving? Which John?
Which living?
Yeah, you have like 1,000 stories here. John must appear more than once.
But did he live more than once?
Yeah, I'm not sure. And then you find yourself puzzled. How do I solve it? And can I solve it? And so we try to focus on corpus question answering. So I can give an example for cases where they naturally occurring in things. In enterprises, it will occur because people know their stuff. People know, your Google Drive. You know what to ask when you're going there, probably.
Hopefully.
And you know what happens in your company. So we try to see what naturally emulates it, and we went for things that people know end to end. So we went for a TV show. We went for Seinfeld, Seinfeld transcripts, and trivia questions about Seinfeld. And these are questions that requires wide understanding. They are targeted at people that have seen the entire show and understand the entire show. So when you're asked a question like, you have the transcript and you are asked a question like, what is George's most favorite alias? And any Seinfeld fan knows that it's Art Vandelay.
Even I know that right now.
Okay.
After the fourth time that we're talking about that.
Okay, that's good.
You did teach me something.
Probably. I hope that you'll watch the show once, so you can know it for yourself. So any Seinfeld fan knows that it's Art Vandelay, but it's not written explicitly anywhere locally in the text. It's not like George says, my favorite alias is Art Vandelay. No, they're just waiting for an elevator and they're looking for some lie. And they're saying, okay, I'll say Art Vandelay. And in another episode, he's answering the phone and he's saying Vandelay Industries. And it's implicit in the text and it appears in many locations. And in some episode, he says, I want to be called T-Bone. But that's not his favorite alias. And any Seinfeld fan knows it. And any RAG pipeline that breaks the data into chunks and trying to do whatever RAG pipeline is doing right now fails miserably on these kinds of questions, on trivia questions generally.
But this sounds something classic that can actually work because the contamination of language models.
Yeah, of course. The same trivia questions, if you feed them directly to GPT without context, you'll get like 80 plus. But if you feed it with context and you ask nicely GPT to answer based only on the context, then you'll drop to the around 40.
Can I ask a bit about that? How can you? Because from my experience, even if you ask specifically the model, there are like prompting tips and those kind of things. But even this is not something that necessarily work. And a lot of the time, the model will actually say the correct answer based on its knowledge.
Yeah, you're right. It is a problem. It's like a chicken and egg problem here. And we did some internal evaluations, eyeballing, meta evaluations on our prompting to check for that. Of course, it can be that Art Vendelay is somehow mentioned in one of the contexts, and GPT already knows that it's George's favorite alias. So it'll just say, because LLMs really like to please their us humans.
It will always say, "Oh, you're right. That sounds so good. You're so amazing." And like, dude, clearly I'm not. Like, why are you lying?
Yeah.
A language model that has no feelings, but
yeah. So you're right. There is this question, and it stands between us and reliable answers for these kinds of benchmarks. But we did see that that feeding that with the right prompt, feeding an incorrect context purposely results in like 0, which is your goal. So this gives us some sort of confidence.
So you tested this explicitly to see that this prompt works, essentially.
Exactly.
Okay. Not bulletproof, but hopefully.
Not bulletproof, but hopefully. Exactly. But as I said, I think many benchmarks suffer from this issue. I don't think we have a good solution other than generating benchmarks ourselves through synthetic data, which is something that we do too.
Okay. Just something that kind of, I think I haven't asked you that before. You've mentioned that this is something that naturally occurs in enterprises, right? You know your drive, you know your whatever storage you use. Is this something that you came across because of research, like researched RAG and whatever solution out there, and you want to find somewhere where RAG fails so you can improve? Or this is something that came because of the business side, from clients, think that we've seen problems that they have, and you stopped and asked why?
So I think that both. We started a very lab-like work on RAG, and we encountered many issues even with the existing benchmarks, and we found ourselves trying to optimize the chunk size. And just let's add the header of this table, and you have here this information. So let's put it in. Anthropic as an interesting work called contextual retrieval, where they summarize the document and inject it into every chunk. And all these attempts proved us that they don't really work. They are not really generalized to other use cases or to new use cases. So when we started to examine it, we saw that the blanket was too short. When we increase a bit the chunk size, we start to lose information. When we decrease it, we start to lose the contextualization. And it's still. And once we got to know the problem better, we found out that there are many questions that, no matter which chunk size I use, are just inherently impossible with this kind of pipeline, the existing RAG pipelines. And we got a validation from the business side too, because no matter how well our pipeline did on our internal evaluations, on public benchmarks, on internal benchmarks that we developed, in the same way that I told you before, like document question answering concatenated. So no matter how many times these things happened, we still got validations from the business side that wait a second, your RAG doesn't really work on my enterprise data.
So you've mentioned, and it's interesting that you went there, because I think that's not like when people talk about RAG, that's usually the blind spot, right? Because R is for retrieval, AG is for augmented generation. Not enough people are talking about chunking. And I'm guessing that it's because there are no benchmarks for... How do you check chunking?
Yeah, you don't. That's exactly the case. Chunking is question aware. It's question dependent. So you cannot test it by itself. I'll add to the pot also parsing. Parsing and chunking are usually overlooked in most of the benchmarks. But chunking is actually something that is not... You cannot actually measure it. Let's take, for example, World War II document that describes the reasons for World War II. One student that is looking at this document and wants his reg pipeline to help him for his exam may ask, for reason number 4 for World War II, please let me know some more. Tell me some more about it. Another student wants the list of reasons. So for the first student, a small chunk that captures only the 4th reason is the best choice.
But this is if there is numbering, right? If there's no numbering,
yeah, of course,
we can get in trouble.
Of course. But for the first student, for the second student, you can say, okay, maybe I need a much bigger chunk that captures the entire list of reasons for the World War II. And I'm not sure that even this chunk is even possible with the tools that most of the people use in order to embed or to index the chunks into their databases.
So what you're essentially talking about is the fact that chunking is not... It's not something that is even stable. There's not, if we said that RAG is not one fit all, chunking is even more not fit all, right? I think the standard chunking, splitting, segmentation, the standard thing is to just give it in a lengthwise, I think.
Yeah, there are many heuristics, but...
You can add some overlap. You can maybe not some overlap, maybe do it in a semantic way where each chunk is maybe in a different length or so. But these are all the tips that I've seen so far, and still it's a problem.
Yeah.
So how can we solve that?
So I think that it's a problem. I'll just take a small detour. It's not the only problem. It's important to say there are many other problems. Parsing, for example, as I said, you usually get your files parsed, and query types that sometimes require different mechanisms. And people are usually overcoming this by adding more and more heuristics to their pipeline. If you'll look at Llama Index or LangChain, you'll see that people are just indexing a summary of the document and a summary of a group of documents and trying to do all these things. But actually, I think these are all sort of patches over the actual issues. I think that another approach that people take, and we took as well, is trying to convert your data into some structured form that allows you to query it in a different way. From a different path. So specifically, there are works like RefRag that are trying to convert the data, going over the data, trying to convert it into some structured form of a graph or of a knowledge graph with nodes and relations, and trying to represent the data this way. We took a slightly different approach, but similar in the thought, where we had the understanding that the enterprise data sometimes acts like a relational DB, but over unstructured files. For example, if you take financial data, or even us as data scientists, we log our results at all kinds of documents. We log new models in all kinds of places. But you have like these repeating patterns of information scattered across many documents in free-form text. So we took the approach of going over these documents, extracting information from them, then querying it with an SQL query.
So we got to the part of the solution.
Yeah.
Finally, I got a lot of texts in the past month that I'm like, why are you such a hater? You're just saying that everything doesn't work. And so now I'm happy to talk about things that do work.
Yeah, it does work. It does work. It's important to say it doesn't solve the entire problem. Some information in the world is sparse, or even a lot of the information in the world is sparse. But it does solve some of the problems. Since we started working on it, we had some traction from a few clients that resonated with the idea, because they have many files, whether it's medical files or financial files or manuals, that has like repeating patterns that they would like to extract and then ask natural questions about, and all the RAG use cases just fail. We saw it with manuals of electrical appliances. When you're asking, my LG washing machine has an error E10. What shall I do? Just failure with your regular RAG.
Throw it in the
pipeline.
trash and buy a new one,
Yeah,
I guess.
That's exactly.
So maybe let's set up the settings correctly right now. What is just describe to me the type of use cases or the type of documents and questions that we're going to explain how to solve with a specific framework.
So maybe let me take you through one of our benchmarks, which is what you waited for so eagerly, the FIFA World Cup benchmark. In this benchmark, we took Wikipedia pages of all FIFA World Cups history. So for each World Cup, you have the Wikipedia page alongside many facts of the World Cup, and we also took in the background tables from Wikidata and Kaggle to complement this information. And based on the tables, we've created questions using an LLM that are SQL-like questions over this data, but are very familiar to any fan that watches football.
All the three out there.
All the three out there?
Three.
I think that we are 4 now.
4, okay.
So I think that any football fan knows its commentator or is saying, this is the first time that Italy has ever relegated or ever qualified for the... And so many things like that. He was the first striker to score more than 3 goals in 2 matches in the World Cup. And these are so repetitive patterns that any football fan knows, or I guess any sports fan knows. And we compiled these kinds of questions. How many World Cups were in each continent? Which country has won the most World Cups? Which country was the second with the second most wins in the World Cup? Stuff like that. Very intuitive questions. We manually filter them with other teams, and we try to come up with a set of questions that feel natural, and you would like to ask them. But let's assume that you don't have the database to do that. You just have the Wikipedia pages. And if you take this to OpenAI responses alongside the Wikipedia pages with file search enabled, you get 5%.
5% out of 100.
5% success, yeah, out of 100. And these 5% are just cases where there was a case where it says that he became the leading top scorer of all times. So there was a paragraph that already answers the question.
So there was a local solution to the problem?
There was a local solution to the problem. Let me just clarify. If you want to answer the question, when was the last time Italy was in the top 3 in the World Cup but haven't won? Let's imagine the process that goes on with a regular RAG pipeline. You retrieve K chunks. Let's imagine that K is 10. And then you say, okay, this time Italy was in the 4th place. This time Italy was in the 5th place. Okay, you have this subset of things. And then you are left. And let's say you are very accurate with your RAG, and all of these items are mutually exclusive, and they are all talking about different World Cups. And you get the idea that in 10 World Cups, something happened. Italy was in some place, but there are 12 more World Cups. So
How
you don't
many?
know. There were 22.
Oh.
So you don't know, unless you have the prior to know that there were 22 World Cups, you are always left with the question, is there an N+1? Do I need to bring another chunk? Do I need to retrieve more content? Do I need more information in order to answer the question correctly? So you're always left with the doubt.
I think it's a bit too football-y for me. Can you maybe give an example of how would this type of question represent a question for maybe finance?
Yeah, you say, I want to, I'm working with customers and I want to engage with every company that has revenue above $10 million over the last quarter.
Mm-hmm.
As soon as I say all the companies, I'm ready to fail with RAG. Unless there was a list somewhere with all the companies that had over $10 million in the last quarter, I'm just going to fail, because you are just going to retrieve 10 or 20 or 50 chunks. And then you're not sure if the 51st chunk has another company.
Gotcha.
And let me tell you another thing. All of the embedding model that we tested, including closed source, open source, and others, fail miserably when they're trying to deal with questions with these sort of predicates, like over 10 million, under 10 million, just doesn't say anything to them. It's just miserable fail.
So, like, I can maybe not ask those type of questions, or we can try something else to solve these type of questions.
Mm-hmm. So this goes back to the solution that we offered, which was try to come up with some sort of schema that describes your data, underlies your data, go over the data, extract information to the schema. Of course, there are so many details here. Even in the World Cup, you have Germany, you have West Germany. Which one is the correct? You think your field is named is country, but then you get South Korea and Japan hosting together the World Cup. The world is messy, but I think the idea remains the same. You try to extract information, and then at query time, you can answer reliably based on this information. This is we simulate what you would want to do in real life. If you had infinite compute, you'd say, the user asked me a question. Let's just go over his entire database and answer the question as accurate as I can. If I had infinite compute and infinite time, this is what I would do. But we don't have this. So we try to simulate it by extracting the data in some structured format and asking the questions efficiently in inference time.
Okay, so you mentioned the word structured. I know you call it structured RAG.
Yeah.
All right, so let's be very, very clear on what happens there.
Mm-hmm.
Saying extracting all the information and put it into schemas, you're essentially creating like another DB, something you can search through with SQL.
Mm-hmm.
Right, so you're taking all the documents, putting every document in some sort of a schema, then put everything in an SQL database.
Mm-hmm.
And then what happened? every time, like the system, you're just throwing away all the documents and all you're left with is essentially the database? Or
No, of course not. We still have the documents themselves, and we have the regular reg pipeline because, as I said, the world is sparse, the world is messy. Many facts and factoids and questions and small information items appear in the document and are unique to a specific document. I would not add to my FIFA World Cup table. Was there an unusual event in this FIFA World Cup? Because this is the nature of things. They are unusual, so you don't put them into your relational DB.
Okay, so how does it look? I have now the system. I have some sort of a query that I want to ask. What goes down in the inference time, let's say?
Yeah, so we try to go for it from different directions. If we can answer, if the information is already there, that's great. We can get it from the SQL DB that we built at ingestion time. Otherwise, we can try to see, okay, can we get it by using our regular vector-based pipeline, which is also, I say regular, but let me put a pin on it. Another option is to say, wait a second, I have already the algorithm to build this SQL DB. Users in the enterprise are willing to wait for accurate answers. I can tell the user, wait a second, I'm building the DB. I'm adding a new field to the DB because I wasn't sure that you were interested in knowing what were the profits of some company.
Of the FIFA World Cup. Oh, so all of a sudden
all of a sudden
we came back to real use cases,
serious use cases. Yeah. So, or how many red cards were there in the FIFA World Cup? Now
I'm more relaxed.
Yeah. Good. So yeah, I think it goes back to what you said. There is no one size fits all here, and this is our understanding of the situation. And this is where I pull the pin out from I said regular pipeline, but based on our understandings and the things that we talked about so far, we are really trying to mitigate the issues that come with chunks, with the chunking issue at the generation time, because even if I found the right chunk, sometimes it's not contextualized enough for the LLM to understand what's going on. So we're trying to overcome these things too by pushing aside as much as we can the hyperparameter of chunk size, building a very strong parsing pipeline, mitigating the peripheral issues that will allow us to retrieve correctly and feed the LLM with the most accurate information.
Specifically, anything about the chunk size that you mentioned?
Yeah, so we're trying to as I said, just get rid of this as a hyperparameter by working with a lot of chunk sizes simultaneously and combining them in a smart fashion. So
I'm hearing a lot of like good quality and like improvement in benchmarks, whether internally or external benchmarks. As probably a self-appointed hater, I do have to say that it sounds that there's like a glare issue here, which is extra memory.
Yeah.
Right?
Of course, memory and latency are the trade-off here. As I said earlier, I think that RAG is an efficiency memory, an efficiency solution. Sorry. It comes to solve an efficiency problem. If you could, you would have gone through your entire corpus at inference time. If you had the compute, if you had the transformer to do that, if you had like the ability to do that, why not? Use your strongest machine to do what you want to do. Unless you have some strong filters that you know that you can say all these documents, let's put them aside, they're not relevant. But otherwise, go through your entire possible documents and find the answer. So RAG in general is a way to do things efficiently. This is how I see it. So it's all like a time memory trade-off. And yeah, we are willing to invest more memory in order to provide better and more accurate answers, because we are what happens today is that people are trying to approximate this process, and we lose a lot in this approximation. And by increasing the memory, we lose less.
So essentially, it's really, I think the thing that comes the most here is that RAG is not a one-size-fits-all, and you really have to make sure you understand what you're trying to solve and then choose the right path to do that, even if it means pay with more memory, a little bit more latency, accuracy first, more databases, more presentation.
Exactly.
Okay, Niv, let's wrap this episode up. I'm going to now ask you a series of questions. Just answer, don't overthink it, okay?
Yes.
Is RAG a solved problem?
No.
What is the biggest problem in RAG benchmarks right now?
They don't consider the entire corpus.
What are the blind spots of RAG?
Parsing and chunking.
How can we build smarter and more sophisticated RAG systems?
I think you need to use heavier machinery for indexing and then find smarter ways to retrieve.
And finally, any tips for AI builders out there?
Be suspicious of your benchmarks and build your own if you can.
Okay. Well, thank you, Niv. It's been a pleasure having you here. Please tune in for more episodes about all the things that you need to know to really build AI solutions.